Welcome to this explainer. Today, we're going to unlock what I like to call the ultimate algebraic cheat code, the binomial theorem. If you've ever stared at a massive polynomial expansion and just felt this total wave of dread, you are absolutely in the right place. We're going to turn all that mathematical heavy lifting into a streamlined, really elegant process.
All right, let's take a quick look at our roadmap. We've got 6 stops today: the algebra expansion problem, unpacking the binomial theorem, the magic of Pascal's triangle, finding specific middle terms, real-world numerical approximations, and finally, the IIT JEE cheat sheet. Okay, part 1, the algebra expansion problem. Picture this. You're sitting in an exam. The clock is totally ticking down, and you're suddenly asked to expand a binomial with a massive exponent, something crazy like a plus b to the power of 5, or no way, even 8. Doing this manually, it's a total nightmare. You literally have to multiply the binomial by itself to get a square, take that whole messy result, multiply it by the binomial again for the cube, and just keep going. It's this brutal, error-prone marathon of FOIL methods and combining like terms. It's exactly the kind of tedious, busy work we want to skip. So let's skip it. Section 2, unpacking the binomial theorem. Here is your elegant escape route. The binomial theorem lets you expand a plus b to the power of n for literally any positive integer n in one single shot. And the secret sauce here is this beautiful little engine called the binomial coefficient, which we write as NCR. That's just n factorial divided by r factorial times n minus r factorial. This tiny formula does all the heavy lifting for us. Now, you might be wondering, are these coefficients just random numbers? Nope. They follow some really predictable time-saving rules. Take the symmetry property. It tells us that NCR is exactly equal to NC n minus r. Basically, the coefficients perfectly mirror each other. Plus, your first and last coefficients, they're always going to be exactly 1. And here's a really fun fact. If you add all the coefficients in an expansion together, their sum perfectly equals 2 to the power of n. How cool is that? Moving on to section 3, the magic of Pascal's triangle. If factorials and formulas feel a little too abstract, check out this beautiful visual symmetry. This is Pascal's triangle. Each row represents your power, n, and the numbers literally hand you the exact coefficients you need. The absolute magic here is that you generate each row just by adding the 2 numbers directly above it. Look at row 5, for example. 1, 5, 10, 10, 5, 1. Simple, right? See how this works in practice? We literally just drop the numbers from row 5 of the triangle straight into our equation. You start with a to the 5th power. Then, as you move across the terms, the power of a drops by 1 each time, while the power of b increases by 1. Slap on those coefficients we found, 1, 5, 10, 10, 5, 1, and you're completely done. We just bypassed pages of awful manual math. Let's kick it up a notch with section 4, finding specific middle terms. What if a test question doesn't want the whole massive expansion, but just one specific little piece of it? Enter the general term formula, written as t sub r plus 1. Think of this as your mathematical sniper rifle. It lets you pinpoint exactly the term you need without writing out 20 others. It's simply NCR times a to the power of n minus r times b to the power of r. Let's look at a real example. Say you absolutely need the 5th term of the polynomial 2x plus 3 all raised to the power of 8. It literally takes 3 quick substitution steps. First, because the formula uses r plus 1, finding the 5th term means our r value is actually 4. Make sense? Okay, next, plug everything in. Our n is 8, our a is 2x, and b is 3. So we're looking at 8c4 times 2x to the 4th power times 3 to the 4th. Do a little bit of arithmetic, and boom, you land right on the answer. 90,720 x to the 4th. You just found a needle in a mathematical haystack without breaking a sweat. Now, a super common exam question is finding the middle term, and test makers love trying to trick you here. You actually have to split your logic depending on whether your exponent n is even or odd. Since the total number of terms is always n plus 1, if n is an even number, you get an odd total number of terms, which means there's exactly one middle term. But if n is odd, you get an even total number of terms, so you end up with 2 middle terms. Let's put that into practice. Say we need the middle term of x plus 2, all to the power of 8. Well, 8 is even, right? That means 9 terms total, so just one middle term.
To find its spot, take 8 divided by 2 plus 1, which gives us 5. We need the fifth term. So we just fire up our general formula with r equals 4. And it cleanly spits out our single middle term, 120x to the fourth. Honestly, using this shortcut is going to save you massive amounts of exam time. But wait, there's more. Section 5, Real-World Numerical Approximations. This stuff isn't just for variables, it is a total game changer for ugly decimals. Imagine you need to calculate 1.01 to the power of 5, but you don't have a calculator. No problem at all. We just rewrite it as 1 plus a tiny fraction, 1 plus 0.01. Because 0.01 is so ridiculously small, the higher powers basically vanish. So we really only need the first few terms. 1 plus n times x plus nc2 times x squared. That gives us 1 plus 5 times 0.01 plus 10 times 0.01 squared. And just like that, you get 1.051. It's a surprisingly simple way to get a highly accurate estimate. If you're tackling physics or engineering problems, this trick is an absolute lifesaver. All right, let's bring it all home with Section 6, the IIT JEE cheat sheet. If you're gearing up for a competitive exam, these 5 bullet points are your mechanical foundation. You've got to know how to expand using coefficients. You absolutely must memorize that general term formula. Always remember an expansion has n plus 1 terms, and whatever you do, do not forget the even-odd rule for middle terms. For IIT JEE aspirants specifically, these 4 focus areas are exactly where test makers will try to trip you up. They won't just ask for a basic expansion. They're going to ask for the coefficient of x cubed in some messy string, or they'll test your knowledge of those symmetry properties we covered earlier. Master the general term formula, though, and you've literally won half the battle. So you now have the tools to completely bypass the busy work. You get the hidden symmetries, the absolute elegance of Pascal's triangle, and the laser precision of the general term formula. The days of endless, error-prone manual multiplication are officially over. Now that you've got the ultimate algebra cheat code, which tedious math problem are you going to destroy first?